So today we'll be going over the airplane problem from the end of the chapter on vectors. The problem reads, an airplane is flying at an airspeed of 200 miles per hour, headed on a southeast bearing of 140 degrees. A north wind, moving from north to south, is blowing at 16.2 miles per hour. What are the ground speed and actual bearing of the plane? Step 1 when presented with a word problem is to locate any pertinent information. So the first piece of information here is the airspeed of 200 miles per hour, followed by the southeasterly bearing of 140 degrees. There's a north wind blowing at 16.2 miles per hour. Second, we take this information and use it to draw a picture. We have a very beautiful picture here provided for us from the book, but to use it we do need to remember our cardinal directions. So we have north, south, east, and west. And the plane is moving southeasterly down in this direction, and you can see that represented here by this red vector labeled C. We've also labeled this with the airspeed of 200 and moving at a 140 degree angle off of due north. Taking those next pieces of information, we have a north-south wind, so that's pushing the plane down this way, moving from north down to south. So we draw our second vector, this green vector labeled B, below C, because that's the direction the plane is being pushed. This little dotted line here is the 16.2 miles per hour that wind is pushing the plane. We do not know the ground speed of the plane, x, which is associated with this green vector B. We've made a triangle. We have 200 on the red, 16.2 on this dotted orange, and x running along this green. Now that we've set up our picture, we can start to put things together to find the ground speed. First thing we'll need to use is the rule of alternating interior angles, which tells us that BCO must be equal to AOC, which is 140. So this angle inside here is also 140 degrees. Now we know one of the angles in our triangle. We have two of the sides, and we need to find the third side, so we can use the law of cosines. Law of cosines, c squared equals a squared plus b squared minus 2ab cosine of c. So we have to identify what we're going to fill in for those variables. We don't know our x, that will become our c squared. So we'll simply write that as x squared moving along in the problem. For a squared, we've got that wind speed. And for b squared, we have the airspeed of the plane, the 200 miles per hour. And our angle that we know is the 140 degrees. We plug all those values into the equation, starting with the 16.2 for a squared, 200 for b, and again a, b, and finally filling in that angle for the value c up here. Taking out that calculator and performing these calculations, we find that 16 squared equals 262.44. 200 squared gives me 40,000. 2 times 16.2 times 200 gives me 6,480. Now for this next step, start by calculating the cosine of 140 degrees and make sure that the calculator is in degree mode, not radian, or you're going to end up with a different number here. So after you've set it to degree mode, enter cosine of 140, and that's going to give you a negative number. Cosine of 140 times negative 6,480 gives us 4,963.97. We add these two together to get the 40,262.44. One more step to add, and we end up with this 45,226.41. Remembering we're dealing with an x squared, we have to take the root of both sides, and we find our ground speed. X is equal to 212.7 miles per hour. So now we know this is 212 200.7. The next and final step in this problem is the plane's new bearing. So keeping in mind that the new bearing is going to be 140 degrees plus this new angle alpha that was caused when the wind pushed that plane from C to B. We have to find alpha and then add it to the 140 degrees. And we can use the law of sines to find our alpha. So we're only going to need two of these proportions for this one, A over sine A and B over sine B, where the little a and the little b represent those distances, which in our case are representative of miles per hour values, and the big A and the big B are where we'll get our degrees from. So we know we have an 140 degree angle associated with that new ground speed of 212.7, and we know we have a 16.2 that's coming from this little orange guy right here, and a sine of alpha. And we do some cross multiplication this way, and we end up with 212.7 times the sine of alpha equal to 16.2 times the sine of 140 degrees. And we rearrange this by dividing both sides by 212.7, and we end up getting this whole equation right here. The sine of alpha is equal to 16.2 times the sine of 140 degrees divided by 212.7. And now that we have this, we can enter this into our calculator, and it'll end up giving us 0.04896. Now to undo that sine of alpha, we have to take the sine inverse of both sides. So sine inverse of here and the sine inverse of here, giving us alpha, and then 2.8 degrees. So now we add 2.8 degrees to 140. We have 142.8 degrees, and that is our new bearing.